Good afternoon, class. This is Geography Grade 12, Term 1, exam revision series and guide for Term 1. Please take note that here we are just going to ensure that Term 1 is completed in style and all work is just done. You don't need to have doubts with your progression. Let's go into our today's paper. I always know that grade 12, you are quite smart, you are so determined. Let's connect and tune right now. We have got our paper that we are going to work on today. As you can see, we have got various questions that are here, fluvial processes that you need to understand. I'm sure these types of questions are quite common and they are also part of our end of term series that we can also write tropical cyclones. I'm sure that you know they always come questions such as those, understanding the characteristics and development of tropical cyclones. We talk about drainage systems and drainage density. We're going to be calculating drainage density again as we go through this paper, and also understanding synoptic weather map interpretation is also going to be quite important for you to understand synoptic weather symbols. So without wasting any time, I want us just to go through our paper and then we can be able to understand and discuss in detail everything that is here in contained. So now, we are given question first here that we are given our first question, which is to do with slope aspect. We have to answer the first one, which says refer to the fig on valley climate. I'm sure this has been given also before. We have talked about valley climates before. We said that is microclimate. You need to understand that climate can be studied at a micro level, at a very small level, which can be either a valley, which can also be urban. In our geography syllabus, we mostly focus on valley and urban climate as typical examples of microclimate. So in this respect, we are going to work on the valley climate. So now, what is important here is that a local wind labeled A, which blows down the slope of the valley, is called. We talked about downslope and upslope winds. So we are saying the wind which blows downslope winds are also called katabatic winds. They are also called katabatic. Downslope winds are also called katabatic, which is katabatic. As you can see, the correct answer is going to be shown by the underlining that I'm going to put under the correct answer there. So it is called katabatic. It is called katabatic wind. It is a wind that actually blows down the slope of the valley. And then we say that it is called katabatic. It is called katabatic wind. It blows into the river or into the stream. And then the code A sinks into the valley bottom as it is dash light and dense. We talk about the sinking of code A to the valley floor. It is because it is what? It is heavy and dense. It is heavy and dense. I'm sure I remember this aspect of aerodynamics with regard to the balancing of air masses and air mass between the cold and warm air. So what happens is that warm air is lighter and it has got more water vapor, so it is lighter. And then we talk about dense, what we call cold air. It is always dense and it is heavy and dense. So it actually sinks. It goes below, it wedges below the warm air. So it is because it is what? It is heavy and dense. Uh, number three, number three, the dash is a zone along the middle slope of the valley where nighttime temperatures remain relatively moderate. We are saying is a zone along the middle slope of the valley where night temperatures remain relatively moderate. We are saying relatively moderate. It is the thermal belt. The thermal belt, it actually identifies The thermal belt identifies a zone along the middle slope of the valley where night temperatures remain relatively moderate. And then temperature inversion, we are talking about when the temperature increases with height. It happens again that the temperature of the air mass that is above has got higher temperature than the one that is below. So in natural understanding, it is supposed to be known that temperature must decrease with height. But when temperature increases with height, we call that temperature inversion. It is because of some scientific explanation that we have given again with regards to air masses and microclimate in respect to rivers. So it is the thermal belt which is along the middle slope of the valley at night time, where the temperature remain moderately it's relatively moderate. And then the air at sea is cooled by dash. The air at sea, the air at sea, we are saying the air at sea, it is cooled by dash, the cooling of the air which is at sea. It is because of terrestrial radiation. We are saying terrestrial radiation is the air. We are saying the evaporation or the movement or the release of heat from the what? From the the land or from the river into the atmosphere. So that process, it is called terrestrial radiation, the loss of heat from the what? From the land. It is a method through which heat is lost into the space, and therefore it causes the temperature to go down or to cool down. It is actually one process that causes temperature to cool down, terrestrial radiation, the loss of heat from the land. We call that, or from the river system, as the heat is released, the incoming insolation, it hits the earth, and then the release of the heat from the earth into the space, we call that terrestrial radiation. And then it actually causes temperature to go down. Number 5, forms when cold air collects on the valley floor at night. What is happening is that we have got frosty pockets. Frosty pockets, they form at the valley floor. Frosty pockets forms when air collects on the valley floor at night. What happens is that the air sinks into the river, and then we say that the cold air wedges below the warm air, and then it goes down there. So what happens is that it therefore freezes into the valley crevices, which now results in frosty pockets being formed. So it is frosty pockets that are formed when air collects on the valley floor at night. Number 6, uh, in the morning, the earth's surface heats up and the valley is cleared of fog through. In the morning, what happens is that the earth's surface heats up and the valley is cleared of fog. It is cleared of fog because of evaporation. Evaporation, when the sun starts heating, what happens is that the moisture or the tiny water droplets that is on the surface or on trees and every other object, it starts to evaporate, so that what happens is that the surface is heating and then the fog is cleared because of evaporation. The application or the absorption of heat as the sun rises, it causes evaporation to take place, which we call that it is the one that heats up and then the fog is cleared. I'm sure that you have seen this quite a lot of times when we have got quite a lot of dew in the morning. We see that the fog is cleared because of the increase in heat, because that is water in its gaseous form. So it starts to melt and disappear because of evaporation. Therefore, it is evaporation. Number 6. And then this wind occurs during the dash in valleys. Uh, the wind occurs dash in the valleys. We are saying this the wind, it occurs during the night in the valleys. It occurs during the night in the valleys. We are saying it occurs during the night in the valleys, which is that number 7, it is night. And then we refer to drainage systems in South Africa, and we complete statements with the various options that are given. We refer to drainage system in South Africa, and we answer column A and column B. So now what is given here is it's a river system that we are given here. And then, like I said, that you should understand that we are looking at a drainage system in South Africa. So in that regard, we are given catchment area, we are given the streams that are there, and some forms of drainage, some river system that is given in this respect. So now, what is happening is an area of drainage basin marked A, which supplies a river with water. An area of drainage basin marked A, which supplies a river with water. What is it called? We are saying A, which supplies a river with water, a point marked A. We are saying point marked A, it supplies the river with water. So what happens is the point where the stream is originating. The stream is starting from point A, so it is called the point of the source is the point where the river starts. So it is what? It is Y. It is the source. A is the source where the stream is starting, and then it feeds water into the stream. Point where two or more streams meet at B. When two streams meet at B, two or more streams meet at B, we call that a confluence. A point where two or more streams meet, it is called what? It is called a confluence. It is called a confluence. So what happens is that the answer is what? A point where two or more streams meet, it is called a confluence, which means the answer is what? It is Z. And then a high-lying area marked C that separates two streams within the same drainage basin. Streams that are within the same drainage basin are separated by a watershed. In simple terms, a point or a high-lying area that separates two streams within the same drainage basin, we call that what? We are saying it is a watershed. A watershed. C, it marks a watershed. A watershed, a high-lying area that separates two streams within the same drainage basin. It is what? It is a watershed. And then high-lying area marked D forming the boundary of a drainage basin. We are saying this one, it is forming the boundary of a drainage basin, 1.24. We call that sorry, we are saying a high-lying area that marks number 3. We are saying a high-lying area that actually separates two streams within the drainage basin. We are saying that it is the what? C. We are saying C. It is the interfluve, not we are saying, so we are saying number C. I was mixing it. Number C, it is the interfluve. It is the interfluve, which means the answer is what? It is Y. The answer is what? It's Y. Y is the answer in number 3. Y is the answer. In this case, it is the what? The interfluve. And then drainage. So now we are saying number 4, it is now the watershed. That is a high-lying area forming the boundary of a drainage basin. We call that a water. That is what we call a watershed. That is a watershed, which is also Y again. It is a watershed. That is a boundary that separates a boundary of a drainage basin, it is formed by a watershed. I'm sure that we have heard and understood about watershed migration or movement. And then drainage pattern that is developed at E, drainage pattern that has developed at E, we are saying at E, the drainage pattern that has developed at E here, we can see that we can talk about a dendritic drainage pattern, which is forming like a branch of a tree. It is called dendritic drainage pattern, which is Z. Dendritic drainage pattern, small stream that flows into a large small stream that flows into a larger river. It is a tributary. A tributary is a small stream that flows into the main stream or into the main river. It is what? It is a tributary. And then the stream order at B, the stream order at B. I'm sure I also had a video where I explained how to calculate stream order. I say that stream order, it is calculated according to the connection and the interrelationship of streams within a drainage basin. So first order streams are the streams that are getting their own waters from the catchment area. They are not fed by any other streams. So if streams of the same order meet up together, they form the next high order. So now I can give you an example of saying this is first order and this is first order. Because they are first order streams meeting together, they are going to form a second order there. So again, we are saying this one is also first order and the other one is first order. They meet here, they are forming second order, which is at point number 3. We can have a third order stream. We can say it is a third order that can be formed there. So now what is happening is that streams, we can have a second or we can have a next order of streams after streams of the same order have met up. They form the next higher order, or the next order is therefore formed. I want you to understand that we can say it's first order is first order, and then we have got second order there, but this one is first order. Again, we are saying it is first order, this one is first order, and then we have got second order there. So because we have got first order here again, and already what is happening is it is forming along a second order, this one. So we can have a third order there. But this one is the first order because it gets its own waters on its own. So what we need to understand is that we can say this can be a low order because we are not having, we are still within the short or the first stream levels. Therefore, it is called a low order, which is what? Which is Z again. It is a low order, which is Z. Area of a drainage basin at which the river flows into a dam. We are saying it is the end of the river. The river ends at its what? It is the mouth. The opposite of source is the mouth. Therefore, the answer is what? Is Y. So what you need to understand is river systems is one other chapter when students are expected to get as much higher marks or totals as possible in terms of river systems. It is quite an interesting and not so much confusing unit or chapter. So please just understand it and we can be able to help each other wherever it is necessary and possible. Keep connected. We have got next question that we need to answer again, which is question 1.3. It refers to tropical cyclone. I have answered another question similar to this one from Gauteng province. So now we are saying a situation overview. Cyclone Tikeled made landfall south of layer of Mozambique as a tropical cyclone on the afternoon of 13 January and re-entered Mozambique Channel via Algoche the following day. It brought severe weather, with Mansuri recording the highest of 400 and rainfall of 447 milliliters on 14 January, and then followed by Marquette, which is giving 240.1 milliliter, and now Nampula as much uh, waters that was given there. So I want us to go to the question, give one evidence of give one piece of evidence give one piece of evidence that indicate that tropical cyclone Dikeled occurred in southern hemisphere. What tells us that the cyclone it occurred in southern hemisphere? We are saying that that is uh, in southern hemisphere. How can we tell that the cyclone occurred in southern hemisphere? If you can check here, we are talking about this is Mozambique. Mozambique is within southern hemisphere. It is in southern hemisphere. It is the presence or Mozambique, the Mozambique channel. We can also talk about uh, the dirty. The date also identifies that that is the month of January, which identifies again it is again in what in southern hemisphere. So what we are saying is the answer is we can talk about Mozambique. I think our world map. Mozambique is in southern hemisphere. We can also talk about the date, which we are saying the date identifies that it was also in the date, which is also given there. We said that it was recorded, and then 13 January, the 13 January, which is given here, the date. Also, we are saying date, that is, we are saying the month of January given there. We can see that it was we identified that this is we are talking about southern hemisphere. How many tropical cyclones preceded tropical cyclone Dikeled? Preceded meaning to say the ones which have happened before cyclone Dikeled. How many cyclone have occurred before cyclone Dikeled? So now we said uh this cyclone, it was cyclone number 4. So we are saying before it, how many cyclones occurred? Dikeled is number 4. So we are saying preceded, meaning to say the ones which have occurred before it. There were how many? There are 3 cyclones that occurred before it. So we are saying the answer is what? It is 3. There were 3 cyclones that took place before Cyclone Dikeledi. How do we know that? We are saying the name of the cyclone is Dikeledi, meaning to say that we said it is a 4th alphabetical letter, which is the 4th alphabetical letter, which I told you again that this must be known that as it is a 4th alphabetical letter, the name of the cyclone is identified by the letter that is the first letter of its name defines the number of cyclones which have occurred within a given place or at a given location. So D is number 4 on alphabetical sequence. So it is before we had got 3 cyclones that hit the place. And then our next question, is therefore saying name the type of cloud that resulted in highest amount of rainfall that was recorded on 14 January in this place. So we are saying the type of cloud that always results in high rainfall on the 14th of January. If you can look here, you see that what happens is that we are saying it is supposed to be known that cumulonimbus cloud is the one that always causes high rainfall from your geography background. I'm sure that you know that the cumulonimbus, it is type of a cloud that results in heavy rainfall, thunder and lightning. And then I expect grade 12 actually to understand such a question because that is what it is. And then next question is saying, with reference to the extract, outline the social environmental impact that tropical cyclone had in Mozambique uh, in terms of 3.14, 1.34. We are saying the impact that the tropical cyclone had in Mozambique. We talk about social impact. We can classify them. Let's start with the social impact. I'm saying one, we talk about the social impact that is there. This can be seen also in the case the cyclone has also impacted 105 schools, 291 classrooms, affecting 250 teachers and students. We talk about 15,000 houses and 43 health facilities were also damaged. We talk about road blockages. These are also given in the essay. Power lines were falling, damaged communication network, and had hampered access to information, particularly in these areas. Approximately customers of electricity were out of power, which is 113,000 people were affected. And therefore, we are saying the impact which this has, we talk about loss of life, we talk about loss of lives of people died, and also injuries which were also seen there. We are saying there is also the issue of 250,000, 250 teachers who were also affected, 250 teachers, and also 18,241 students affected, 241 students who were affected. We talk about access to information was stopped. It also hampered access to information. It also hampered access to information. We also talk about a destruction of houses, which we are given that 15,000 houses. 15,000 houses were destroyed. 15,000 houses were destroyed. And then we can talk about also environmental impact. We also maybe need to look at the environmental impact also that we have also in this case. I want to talk about road blockages. Road blockage, the blockage of roads. We also want to talk about the damaged communication network. Damaged communication network. We also maybe want to talk about the pollution of water reservoirs, pollution of water, water resources, which are also affected because of these problems. The pollution of water resources, that must also be understood. And again, even animals also affected. So those are some of the things that we need to understand. And then the next question is saying, in a paragraph of 8 lines, discuss strategies the government of Mozambique could implement to reduce the impact of tropical cyclone. Strategies to reduce the impact of tropical cyclones. We said these are quite a lot of them. Strategies to reduce the impact of tropical cyclones. Strategies to reduce the impact of tropical cyclone. I want us to note that there are quite a lot of them which we can give. I say strategies to reduce impact tropical cyclones. What can be done to reduce the impact of tropical cyclone? We talk about one, reinforcing existing infrastructure, strengthening existing infrastructure. Infrastructure must be made strong. Strengthening existing infrastructure that can help. We also talk about erection of, we talk about early warning systems, putting early warning systems in place, putting early warning systems in place. People must be informed through our meteorological department. There must be information that is given to people about the possibilities of tropical cyclones that might also come into that might also affect our people. And then we talk about evacuation protocols and drills, which must be education of people. Evacuation protocols and drills. They would also help our people not to be impacted quite seriously by tropical cyclones. We can also talk about built above flood lines or coastal zoning. Building houses above flood lines. It can also prevent the effects of floods. And then we can talk about improve accessibility to evacuate people. Improved accessibility to evacuate people. Improved accessibility to evacuate improved accessibility so that people must be removed from wherever they are affected. We talk about storage or provision of clean water and food supplies. Provision of clean water and food supplies. Provision of clean water and food supplies to people who are affected by these tropical cyclones. Otherwise, we might also need to talk about rescue personnel to be on standby, having Rescue personnel. Rescue personnel to be on standby is also very important. To be on standby. We are talking about e.g., for example, we can talk about police. Police can assist in this case. We can talk about medical persons, medical personnel. It is quite important that we have them also on standby for them to assist. In maybe in other areas we can talk about also good forecasting, which must also be given in terms of use of media to update people regularly. Good forecasting and media to update people regularly with regards to possibilities of tropical cyclones so that people are well prepared. And then we also maybe need to talk about moving people to higher ground. It can also help. People must be moved to higher ground in order for them to avoid serious problems that might arise after tropical cyclones have hit them. And then lastly, I might also want to mention the issue of stocking up emergency supplies and necessities. Stocking up emergency supplies and necessities would also lessen the problems which might arise when people are affected by tropical cyclones. So that is some of the points that you need to look at and you should consider when it comes to questions such as those ones. And then we have got our next question, which is now question 1.41. 1.41, it says this question 1.41, it says define the term drainage density. Define the term drainage density. Drainage density, I'm sure that quite a lot of times we have also seen that I answered this question again before, but for the interest of others, let's just recap it again. It is actually, when we are looking at drainage density, it actually tries to evaluate the total length of streams in a drainage basin. It is the total length of streams in a drainage basin. In a drainage we are saying in a drainage basin, that we need to understand that divided by the total area of the drainage basin. Divided by total area of the basin. We call that drainage density. So now, what we are talking about is that the relationship between the length of the streams in the drainage basin and the size of the drainage basin, it defines the drainage density. I'm sure that you understand the relationship between the length of streams in a drainage basin versus the size of the drainage basin defines what you call a drainage density. So, which one of the drainage basins, A or B, shows the drainage density during dry season? We are saying which one, A or B, shows drainage density during dry season. So obviously, like in a dry season, the number of streams must be few. So what happens is that B can be the answer. We are saying B can be the right answer here. It should be B, because when it is a dry season, the number of streams are supposed to be very fewer. It is B, number 1.34. It is B. B is the right answer. And then support your answer in this case. Support your answer. If you see here, our answer can be supported by saying, what we are saying in this case is that we are saying in this case, what needs to be understood is that A, as you can see, there are more streams that are there. So the total length of the streams in A is longer than that of B. There are many first order streams in A, which shows that there is a lot of rain that is taking place or that is in the area. So as you can see, in this case, question 1.34, 1.4.2, 1.4, 1.4.3, the reason it shows is that it has got very few streams, which shows that that is the area. And then we are saying compared to A has got many tributaries. A, it has many streams. As you can see there are many streams in A, which also the total length of streams in A is longer than that in B. Many streams which has uh, bigger length, than what? Than B. And then we are saying again, what happens is that we have got many first order streams in A are present. Many first order streams in A. That represents that there is too much rainfall that is taking place. We have got more rain in A, which is shown by many first order streams that are forming there. They are forming as a result of more rainfall. And then question 1.4.4. Next question 1.4.4. It says name the underlying rock structure where the stream pattern in figure A forms. This one we are seeing stream A, the underlying rock where we have got the underlying rock whereby we have got this, the underlying rock where we have this. I'm saying that it is actually uniformly, it is found where the rock is uniformly resistant to erosion. Name the underlying rock structure where we are saying it occurs where the rock is uniformly resistant to erosion. Where the rock is is uniformly resistant to erosion. The rock is uniformly resistant to erosion. We can have such a rock, we can have such a type of drainage type. We say that the type of drainage pattern, the dendritic drainage pattern forms in homogeneous rock structures which are having the same properties. And then what is the characteristic of stream A? What is the characteristic of stream pattern in fig A? 1.4.5. The characteristics of this one, it actually, there are quite a lot. We are saying it looks like a branch of a tree. It looks like branches of a tree. We also say that tributaries, they join each other. They join each other and mainstream at acute angles. At acute angles, which means that they are joining at very short angles, at very small angles. That we can see all this on the graph, on the infographic that we are having there. We are saying, if you look at this graph here, the small streams that are forming there, the small streams that we are seeing, the tributaries are joining the mainstream at acute angles. It looks like a branch of a tree. And then 1.4.6, it says describe the factors that may have resulted in drainage basin, factors that may have resulted in density, resulted in to the drainage density in B. The drainage density in B, what might be the factors that might have caused this one? We are saying the factors that might have caused this drainage density in B, we are looking at B class. We are looking at that B there. What might have caused it? What you need to understand is that it might have been caused because of one, we can talk about the rock type and permeability. Rock type, and permeability. What we mean is that there is impermeable rock. We are saying that impermeable rock might also promote high drainage density as more water more water more water cannot easily infiltrate the ground. So what we are saying is that this structure in B, it might have been caused because the rock type and permeability, it is quite impermeable surface or geology. It is actually, we are saying in this case, impermeable surface or geology will cause more runoff. However, in the situation that we are seeing, the situation in B, it shows that the surface is quite permeable. We are saying the surface, it actually causes more water to infiltrate in B. Most of the waters, it infiltrates into the ground. Most of the rainwater infiltrating into the ground. It infiltrates into the ground, hence few streams are formed, resulting in few streams. Few streams are formed. Therefore, we don't have many streams in B there. We can also talk about the gradient. The gradient can also be a factor with regards to formation or affecting drainage density. Gradient affecting drainage density. So what we are saying is that steep gradient promotes high drainage density as more water runs over the surface, but also gentle gradient, gentle gradient, gentle gradient allows more water to infiltrate into the ground than steep gradient. So steep gradient class, it causes more runoff, and like gentle gradient, more water infiltrates and few streams are formed. And then we can talk about vegetation cover. Vegetation cover. More vegetation cover means less runoff. More vegetation cover. More vegetation cover means less runoff and low drainage and low drainage density. That must be understood. In that case, we also maybe talk about soil moisture. Soil moisture also affecting. We can also talk about soil moisture. Soil moisture. If saturated soils promote high drainage density, as more water cannot easily infiltrate into the ground. We are saying saturated soils may promote, they may promote more runoff than infiltration, since the water cannot infiltrate into the ground. Water cannot, it cannot infiltrate into the ground than dry soils. So what you need to understand, class, is that the amount of moisture that is already in the soil before it rains defines how much water can infiltrate or can sink into the ground. So if there is too much water in the ground before it rains, we call that antecedent moisture. The moisture that already exists in the ground before it rains, that also defines the rate of runoff, which again, the rate of runoff predetermines again the drainage density. So if runoff is high, it means drainage density also can be what? Can be high, because more streams can be formed. But situations and factors that tend to reduce runoff will always cause less drainage density. So vegetation cover, soil moisture, rock typing, the underlying geology, and also gradient are all factors determining the rate at which streams can form over a given terrain or on a given landscape. We need to take note of these factors. And then question number 5, it's a synoptic map again, a weather map, which we also need to just quickly look at. And as I've said, it's all about understanding synoptic symbols that are used to define weather factors. So identify high pressure cells labeled E and F. Identify high pressure cells that are labeled E and F. High pressure cells that are labeled E and F. We have got E. Our E is given here, and then our F, which are labeled E and F. Our F is also given on the other side. So now what we need to understand is that if you look at this, I have already given the high pressure cells that are found in these positions. So E, you need to know that E is South Atlantic high pressure cell. E is South Atlantic. It is South Atlantic. I'm sure that we have known this one, South Atlantic high pressure cell, which is South Atlantic anticyclone. Sometimes they call it that way, or we can say South Atlantic anticyclonic. That is E, and then F. F is always known that it is South Indian high pressure cell. F, it is South Indian high pressure. I'm sure these ones, class, we are quite aware. We have got Atlantic this side, and we have got South Indian on the other side, which we always say that the Indian, it is always on the other side. And then we are saying the Atlantic, it's also on the far left side. It is also there. The Atlantic and Indian supposed to be known there. And then we have got, of course, the Kalahari, which is going to be within the inside or within the interior there. So now I'm sure this is known. And then the synoptic weather map depicts summer or winter conditions. This again, I have given you that we need to be able to tell based on we can tell because of the overcast conditions, the presence of the cold front and so forth, which are also available in terms of also air movement on this. So it is actually, as you can see, we are saying we had got the predominance of the cold front that we are seeing there. And then what is happening is that it identifies that this can be a winter, this can be winter weather conditions, and state two pieces of evidence to prove that we said that this can also be told because of the cold front, which is present number 1.15, 1.53, 1.5.3. We are saying pieces of evidence. One, it is the cold front is closer to the southwestern Cape, which we can see there. Cold front is closer to southwestern Cape. The cold front is closer to southwestern Cape, is closer to southwestern Cape. That is one point there. Number two, that can also explain that it is also the presence of the mid-latitude cyclone that we can see there. The presence of the mid-latitude cyclone. The presence of the mid-latitude cyclone is also another evidence, presence of mid presence of mid-latitude cyclone. And then I can as well talk about the South Indian high pressure cell are both further north together with the South Atlantic high pressure. South Atlantic high pressure cell and South Indian high pressure cell also. They are both further north, as you can see there. They are much north. You are seeing that these are much in the north. They are further north. And you can see again here, it is also more or less the same position. So what we are saying is that the South Atlantic high pressure and South Indian high pressure, if they are more, if they are far up there in the north, it means that it is also in winter. South Indian and South Atlantic high pressure cell are further in the north, both are both they are both further north. That identifies to say it is winter. We are on question 1.5.3. Evidence that suggests why we say that it is winter is because of the cold front closer to the southwestern Cape, and again the presence of mid-latitude cyclone. The South Atlantic and South Indian high pressure cell are both further north. They identify that position in winter. And then number 4, describe the circulation of air at the weather station or weather system marked G. The air circulation at G, air circulation, which is, we are saying air circulation at G, uh, what we need to understand is that in at G, what is happening is that at our weather station here, we can see that there is the air is moving. We are seeing that it is what? It is a clockwise circulation. So a clockwise circulation similar to the other paper of uh, the Gauteng paper that we just also did previously. We are saying that it is actually a clockwise circulation that we can give. Is clockwise. It is a clockwise circulation. And then we are saying number next, it says describe the common weather, the common wind associated with this one. It is associated with the beige winds. And then we've been saying identify weather system H. H, we say that it is a mid-latitude cyclone. As you can see, we are saying H. I have already marked it again that it's a mid-latitude cyclone. That is there. It's a mid-latitude cyclone. Mid-latitude cyclone, which we can see there. We are talking about the overtaking of the warm front by the cold front, which would also need to be understood as it comes there. So identify H. Those are the questions that need to be answered as it comes to these kind of what we call climatology or physical geography that we need to understand. I want to appreciate your time and always wish you the best and good time in your revision, in your exams, until we meet in new other videos that are loading. Term 2 work class, I say that please join membership. subscribe to the channel so that you won't miss any piece of work that we are working out here. It is for our own benefit and our own good. Don't miss uh, national funding by failing grade 12. Here we support you to the end. Have a great day and all the best in these all coming exams. Thank you.